Hello everyone. Today's topic is mathematical induction. Broadly in mathematics we have two types of reasonings. One is inductive reasoning and second is deductive reasoning. Mathematical induction or inductive reasoning is when you support a general statement with the help of specific examples or some particular statements. So inductive reasoning is a process of supporting general statement by a series of particular ones. When we use mathematical induction to prove anything, how do we prove? So, in the proof of mathematical induction, you will always be given some statement. It could be in terms of an identity that something always happens, or it could be a statement, or it could be some inequality. So there are different types of questions you may see, but in all types, in all questions, you have to follow certain steps. So what is the flow here? So we check the validity of the given statement for the smallest integer. Usually it's 0 or 1. Sometime in question they give you where n value of n is 3 or more, 4 or more. So you have to select the smallest integer appropriately. That satisfies the conditions of the statement, or we have to check the validity of the statement using the smallest integer value. Second, we assume that the statement is true for some arbitrary integer k, and this is called inductive hypothesis. So basically, to make it simple, first you check if your statement is true for the smallest possible integer value. Second, you assume that your statement is true for n is equal to k. What is k? K is some integer. Then we prove that the given statement is true for the next value of the integer, means it is true for k plus 1. So when we prove it is true for k plus 1, we take inductive hypothesis as a result, right? So if you are able to follow all these steps successfully, it means you have proved the given hypothesis with the help of mathematical induction, right? Now, before we further continue, let's have a look at an example. It will make your thinking more relevant in case of mathematical induction. So have a look at this example. Prove that n squared plus n is always divisible by 2 for n belongs to z plus, means for all positive integers. So what is the smallest integer value here? 1. So 1, 2, 3, 4 and so on and so forth. So we have to prove that for all positive integer n squared plus n is divisible by 2. This statement could have been prove that n squared plus n is an even number, right? So how do we do this? Proof. First thing, you can assume the given statement as Pn. Later it's easy to write and substitute. So let Pn is equal to n squared plus n. The first step was to check the validity for n is equal to the smallest integer value, which is 1 in this case. So what is P1? P1 will be 1 squared plus 1, that is 2. And that is divisible by 2, right? Now we assume that this statement is true for a general value of n, which we assume as k. So let pk, which is k squared plus k, is divisible by 2. So when you have assumed it is divisible by 2, this is a result that you can use anywhere. And what do you need to prove? You need to prove that when n is equal to k, then k plus 1 squared plus k plus 1 is also divisible by 2. So consider pk, which is k plus 1 squared plus k plus 1. When you simplify, it gives you k squared plus 2k plus 1 plus k plus 1. Rearranging, you get k squared plus k plus 2k plus 1 and 1, 2. Now, we will use our reasoning. K squared plus k, can we write k times k plus 1 plus 2 times k plus 1? Now this k times k plus 1 is divisible by 2. This was our assumption. So if we take from inductive hypothesis, this is pk, which is divisible by 2, and 2 times a number is always an even number, which is always divisible by 2. It means pk plus 1 has 2 terms and each term is divisible by 2. Hence pk plus 1 is also divisible by 2. Now since you have completed all the steps, so you can write hence, or it implies, by the principle of mathematical induction, n squared plus n is divisible by 2. That's all you do. Usually in IB exam, this question carries 7 to 8 marks. This is really important, and what you need to do, follow certain steps. These are the steps that you have to follow. Now, the question is, why does it work? When something is true for 1, you assume true for k and you proved for k plus 1, then how can we generalize? What if it is not divisible by n is equal to 73, n is equal to 137? How do we know whether it is divisible? That is why we have the principle of mathematical induction. Now, how does it work? Have a look at this. Why does it work? Now, when you prove that something is true for n is equal to k, and it has to be true for n is equal to k plus 1. If you recall, we assumed that that statement was true for n is equal to k, and then you proved it is true for k plus 1. So what we are doing is, by proving that if something is true for k, it has to be true for k plus 1. If you are able to prove this, you are proving that when it is true for 1, it has to be true for the next number, that is 2. If it is true for 2, it has to be true for 3. If it is true for 3, it has to be true for 4. So in this process, what is happening? So like dominoes effect. If it is true for 1, true for 2. True for this, true for next. True for this, true for next. So in this process, the formula becomes true for each value of n. And that's how principle of mathematical induction works. Right? I hope this video was useful. If you like this, found this video useful, please consider liking it, subscribing it, sharing it with your friends, and don't forget to press the bell icon so that you should be the first person to get notification when a new video is posted, right? So all of you take very good care until we meet again.